Hello and welcome to my channel. Today I want to check out how to speed up FET by using multiple cores. If I generate a timetable and observe the task manager in Windows, then you can see that only around 1/4 of my CPU is used. So it looks like FET uses only a single core to generate a timetable. Checking the detailed view is strange, since all 4 cores are used only partly. In fact, FET uses only a single thread to generate a timetable. It is better visible with Raspbian OS. As you can see, one core has a 100% workload, while the other cores have nearly nothing to do. Let's check the same with Ubuntu on my 2-cores CPU. The first core is blue and the second core is orange. As you can see, FET uses only one core and sometimes swap to the other core. That isn't done by FET. The Linux kernel swaps the workload of the cores sometimes. In fact, Windows does it too, just faster. Have a look at Fritzchen's Fritz YouTube channel. Some times ago he filmed another 4-core CPU with a thermal cam while running Cinebench, using a single thread only. You can see that Windows always uses another core to render the picture. The advantage is that one CPU core won't get too hot. If a core is not too hot, then a modern CPU can increase the clock frequency. The disadvantage is that the cache of the new CPU must be updated. So on the other hand, it might be even a bit slower to use more cores. As you can see, macOS swaps the single FET thread between 2 cores only. But that is in fact fine, since the 2 cores are only hyperthreading cores. I will investigate hyperthreading and simultaneous multithreading in another video. So why doesn't FET uses all 4 of my cores with 100% workload? It might increase the speed 4 times by doing this, doesn't it? It's sadly very difficult to parallelize the generating algorithm. Even if we could parallelize 50% of the algorithm, it wouldn't be 4 times faster. It would be less than 2 times faster. As you can see, even with over 30,000 cores, it would be only 2 times faster. That is why FET uses another approach. We just generate several different timetables at the same time. Let's assume the first core sorts the dataset in 5 minutes, and the second core also sorts the dataset in 5 minutes. In this case, sadly, there's no speed up, so this idea won't help. As you know, the times to generate a timetable are random. So, if the first core needs 5 minutes to find a solution, but the second core already finds one after 1 minute, then it is 5 times faster. If I want to generate 2 timetables at the same time, then I only need to use the generate multiple dialog in FET. Of course, you can do it similar if you want to use all cores. It is fine if you don't use the computer for other tasks or only for a simple task like using an office tool to write documents. If you want to use your computer at the same time for other tasks, like watching or recording videos, then it is maybe better if you don't use all available cores. But does this work in real life? I generated 160 timetables from my real dataset and imported them into LibreOffice Calculator. The first timetable was generated after 1 minute and 23 seconds, so after 83 seconds. It took around 2.2 hours to calculate all timetables. The fastest solution was found after just 18 seconds, and the slowest solution was found after 138 seconds. The average is 48 seconds and the median is 45 seconds. But as you know, I don't need 160 timetables. I only need one. Let's assume I'm using 2 cores to generate a timetable. So if the first core needs 83 seconds to solve the timetable and the other core needs 26 seconds to solve it, then it speeds up around 3 times. In the second example, the first core needs 35 seconds, but the second one needs 47 seconds. So in fact, the second core doesn't help, since I still need 34 seconds to solve the first dataset. I calculated this for all 160 timetables. Of course, the total minimum is still 18 seconds, but the maximum is now only 63 seconds. The average is 36 seconds and the median is 34 seconds. So using 2 cores will of course speed up 2 times if I generate all timetables. But in real life I only need a single one. And for this it is sadly not 2 times faster. I did the same calculation similar for 4 cores and 8 cores. So with 4 cores, the first timetable would be solved after 26 seconds. With 8 cores, the first timetable would be also solved after 26 seconds. I done this calculation again for all 160 timetables. Of course, the minimum stays at 18 seconds, but the maximum, average and the median decrease. If you compare the single core average with the 8 core average, then you will see that it is only around 2 times faster. This is theory so far only, so I repeated the test one more time by generating on all of my 4 cores. The total time decreased from around 2 hours down to 30 minutes, as expected, 4 times faster. So I repeated the same calculations in LibreOffice once again. The exact values are of course different, since the seeds were different, but the total results are very similar. I can expect a result 2 times faster if I'm using 8 cores. But this is an easy dataset. What about more difficult datasets? I used my original dataset again, but decreased the teacher's max gaps per week constraint down to 2. The total time to generate all 160 timetables was more than 2 times slower. The fastest timetable was solved in 37 seconds, while the slowest one took nearly 400 seconds. As you can see, the median is always slightly lower than the average. And again, I calculated that it is around 2 times faster to generate a single timetable if I use 8 cores. But this timetable is still not difficult. I decreased the teacher's maximum gaps per week constraint one more time down to 1. The total time has increased very much now. It was around 80 times slower. The minimum was around 5 minutes to solve a timetable and the maximum was over 17 hours for a single one. If you compare the average of a single core versus 8 cores, then you will see that it is around 4 times faster now. Also, the median is lower than the average now. I assume using 8 cores will speed up more if the timetable becomes more difficult, and the median might differ more from the average. But now they take too much time on my old hardware. I might investigate some more as soon as I have a faster CPU. That's it for today. The next time I will talk about how to speed up by using the time limit. Have a nice day.